Hello guys, in this video I'm going to show you how to solve reverse and invert magic problem. So given a binary matrix representing an image, we want to flip the image horizontally and invert it. So two step: flip then invert. Right? To flip an image horizontally means each row of the image is reversed. So for example, 011 horizontally results in 110. Right? To invert an image means that each 0 is replaced by 1 and each 1 is replaced by 0. For example, 110 results in 001. Right? So here is a example, input example. Right? With this input we expect to get this result. So very clear two steps. So how to reverse a reverse every row of this input. It's pretty simple problem. To reverse this matrix, wanna just reverse every we iterate to every row, then reverse each row, and in order to reverse a row which is an array, we just simply swap value from two end of the array, right? So we'll start with a name and start, and we swap the element with the corresponding element in the other end, right? So we'll keep doing that until it reaches the middle of the array, right? So we're done with this one. That's basic idea. To invert a in order to invert, we can use bit manipulations here, a technique on bit manipulations. So for example, the flip the bit when I saw that bit with 1, right? So for example, 1 saw 1, so no, so for example 0 saw 1, so it will produce 1, right? Which is reverse of reverse bit of 0, right? We're trying to solve the bit with 1, the current bit with 1. Okay, so 1 saw 1 will produce 0. Still remember it? For saw operations, two different bits will produce 1, and 2 bit that is the same will produce 0. Okay, so as you can see, by doing operations with 1, we flip whatever the bit is. 0 will be 1 and 1 will be 0. So that is it. Let's try to write code here. So we're trying to we're we're trying to reverse doing reverse part first, right? So to reverse, I'm gonna look through the matrix, right? Each item will be the row itself of the matrix. Okay. So how to reverse the row here, right? As we discussed earlier, uh, wanna start from one end, right? Wanna start from uh, index 0, right? Go all the way to the middle, let's say. But how? Uh, but what will be how we calculate the middle here? Because there can be different case, which is, for example, 1, 2, 3. So obviously 2 in the middle, right? But 1, 2, 3, 4. Then what will be the middle here? Actually, there are two middle numbers, which is 2 and 3. And we want to uh, loop all the way here, all the way from 1 to 2, right? And we stop after uh, number 2, right? So here we have 3 numbers. Then we get the middle node. 3 divided by 2 is 1.5, right? And can be round down to 1, right? Which is here the index, which is 2. So I will go all the way from here to here. Okay, the second case, so the sign is 4 divided by 2 is 2, right? So uh, 0, 1, right? So is probably we want to start from I equal to 0 as long as I is still less than the what the length of the array divided by 2, right? This will give us uh, okay, so I, as long as at floor I want to, no, probably don't need to uh, mm, 0, 1. Okay, as long as is row dot length divided by 2 I plus plus. So if row dot length is even, in this case is 4, right? I will run from 0 to less than 2 here, which is 0 to 1. In this case, if this length is odd, then 3 divided by 2 is 1.5, less than I less than 1.5, so I is from 0 to 1, which is what we want. You may think that we don't need the middle element here, right? But actually, probably we will need it in this part, which is invert. From 0 to 1, right? So if we skip the middle one, then if we skip the middle one, we may not invert it correctly here. So yeah, let's go with this direction. Okay, how to reverse it? How to reverse here? Basic idea is to just swap two elements, right? Swap what with what? Swap the current number, current bit with the corresponding bit from the other end, right? So current bit is row at index I, and the corresponding one will be row dot length minus 1 is the last one, is the last one, is the last index, right? And minus I. So if I equals 0, which is the first element, then the corresponding one will be minus 0 a I 0 here, so it will be length minus 1, which is the last one. So as we increase the I here, I is 1 for example, then here we minus 1 mean we go left, right? Go left from the right. So in order to do swapping here, we just change the order here, right? So this one will come first. It is to, let's say y. I'm gonna extract it out into a variable y. This, so I is a left, let's say. Okay, the last step is to invert the bit here, right? Invert the bit at right and invert the bit at left, right? So for example here, this bit with this bit, right? Let's say for example this one, we first We start from here, right? We swap with it corresponding, which is 1 here, so it will become 1 1 0, right? Then we invert the current bit and the corresponding bit also, right? So it will be again 1 to 0 and 0 to 1, which is again become the same as this, the original one. So how about the middle one? How to solve the middle here? Like if we swap the middle, its corresponding is actually the middle, right? So we'll swap with itself. It will be the same here. So because it will be the same here, so we go to the invert part, right? 1 will be 0, right? So we expect here to be 0. So to as we discussed earlier, in order to invert a bit, we will solve that bit with going to solve that bit with 1, right? So probably there are two cases here. If the left is different than right, if the left is different than right, we're gonna flip left and right, which is row left equal to row. So with 1, same here, want to flip the right as well. But if else, it means left is equal to right, whereas in the middle one, left is same as right. We probably just want to invert 1. Okay, that is it. Yes. Ciao. Bye. Okay, it works. But I wonder if we can do something shorter than this. There's a lot here. There's a lot going on here. How about doing the reverse right here? Like I will invert the number first, then I will invert the number first and assign to here. I invert the right first, the number right first, then assign here to left, which means we do something like this. And here same, I will invert the left first before assigning to number right. So is that work? Is it work with the case left and right equal? If left and right are equal, it means I will first invert the middle here, 0 to 1, reassign to here, which is the middle. So the middle now is 1. Okay. But when I do the second operation here, oh, it will still work, I think, because row right and row left here is the same at the beginning. Okay, this will still work because it's the same as this operations is just same as we're doing something like we first like doing something like let temp right. Okay, here like we store the current value in to a temporary variable temp left, right here. So I will sort with one here to invert it. I mean we do not modify this the number here, right? Just assign to. So after here, I will do a swap like row left equal to temp right and right temp left. I guess it is the same. Okay, it works. So this line is the same. Just to show you how it works behind the scene, behind this magic syntax. So that is it for this video. Thanks for watching. See you in the next one.